March 2026, residents along the coast of Western Australia woke up to a morning without a sunrise. Instead, a thick, suffocating crimson fog rolled off the desert and swallowed the sun, plunging coastal towns into a deep, blood-red twilight. These images are real, documented atmospheric anomalies that occurred in Shark Bay and Exmouth. While the footage looks like a digital filter or a scene from a science fiction movie, every frame was captured by residents on the ground. Witnessing a familiar home warp into a hostile Martian landscape triggered a wave of environmental grief among residents. Psychologists noted the immediate human reaction was defined by a profound sense of existential threat and helplessness. Standard Australian dust storms are typically orange or yellow, driven by the winds of a cold front. This event was different. The dense, dark crimson indicated a much more powerful and rare atmospheric process. Severe tropical cyclone Narelle produced the force required to swallow the daylight. To understand how a massive ocean storm weaponized a desert, we have to look at the mechanical violence it brought to the coastline. When the Category 4 storm hit Exmouth, it brought the full weight of a severe tropical system. Wind gusts exceeded 250 kilometers per hour, turning the air into a chaotic, destructive force. These severe cyclonic winds ripped roofs off buildings and shredded critical emergency infrastructure. The conditions became so dangerous that 50 people were forced to abandon a local evacuation center after the building itself sustained critical wind damage. While the wind destroyed homes and businesses below, its most significant work was happening high above the ground. Cyclone Narelle acted as a massive transcontinental vacuum cleaner. Its intense internal physics were pulling up a geological payload from the interior, preparing to distribute it across the coast. That payload was the outback itself. The Australian interior is covered in ancient, heavily weathered soils, exposed to the elements for millions of years. This soil contains high concentrations of iron oxide, specifically hematite. This is the exact compound that gives rust its color, and it provides the Australian landscape with its iconic rusted red appearance. Record-breaking heat preceding the storm caused the desert surface to flash dry. This process stripped away all remaining moisture, leaving the heavy hematite topsoil incredibly loose and weightless. Narelle's compact and ferocious wind field then vacuumed up billions of tons of this iron-rich topsoil, hoisting it thousands of meters into the troposphere. Billions of tons of iron suspended in the atmosphere physically shifted the optical properties of the sky, changing the way sunlight reaches the Earth. Normally, sunlight strikes tiny air molecules, scattering short blue wavelengths to make the sky blue. This is Rayleigh scattering. But Narelle's massive hematite dust triggered Mie scattering. These giant particles block blue light. Only the longest, red wavelengths navigate this dense filter to reach the ground. This blood-red sky was not an illusion. It was the visual proof of Mie scattering occurring at a scale only a megastorm could produce. Tracing Narelle's math backward reveals a highly unusual 5,500-kilometer journey. The storm crossed 3 different Australian jurisdictions, moving from east to west in a trajectory that challenged traditional forecasting models. The storm's birthplace was the Coral Sea, an area experiencing extreme thermal anomalies in the weeks preceding the strike. This map shows the ocean state. The Coral Sea recorded its hottest summer in history, hitting 30 degrees Celsius. This superheated ocean acted as a thermal battery, injecting Narelle with immense energy to survive a rare transcontinental crossing. While a warming planet may lead to fewer total cyclones, the systems that do form are hypercharged. These storms absorb more heat and moisture, making them vastly more intense when they finally reach land. The immediate industrial impact was severe. Major global gas plants in the Pilbara region were forced to shut down operations as the cyclone approached, creating a crisis that reverberated through international energy markets. The storm's legacy also extended beneath the waves. As Narelle moved offshore, it dumped its massive payload of iron-rich dust into the nutrient-scarce waters of the Indian Ocean. This sudden influx of iron acted as a nutrient buffet, It triggered a massive, explosive phytoplankton bloom, so large it was clearly visible from space. Cyclone Narelle's journey and its blood-red sky serve as a cinematic warning, a portrait of Earth's compounding climate hazards, colliding in real time.
Thank you for watching.